So in version 18, we got the Voronoi Fracture object in Cinema 4D, which basically you just get any old object, drop it underneath it, and it breaks it up into these lovely fragments and shards and stuff. We can raise the amount of shards, we can lower it. It's really quite a versatile, lovely thing. So anyway, let's go back to 20 shards. One thing I see when I look at this is that I want this to explode in a really nicely way. And, you know, like, I don't just want to apply a dynamics tag and have them just drip to the floor like this. Look. I don't find that too interesting. However, we don't have in Cinema 4D, we don't have an explode effector. There are some really terrible things, like, you know, there's like the modifier. I'm not even going to show you that stuff because it works so badly. If we take the dynamics tag off our Voronoi Fracture and we go into our effector here and we do the push apart effector, it gives us a somewhat explosive kind of look. So let's just alter the radius here and we can see our pieces are being pushed apart from each other like that. And if you look very closely, if I put a tracer object on this, you'll see the paths that they take when we animate this push apart effector. So if I just animate that over time, let's do to here, let's do 70. Take a look at what happens to these fragments as they push apart. Now, that wiggliness is because each one has a radius and they're pushing up against all of their neighbours. Now, you can take your iterations down to 1. Let's try that again. And we get a lot cleaner results. But still, it's not very explosive. So let's try and push our keyframes close together. Let's see what happens there. Bah! Okay, bit better. Maybe, you know, maybe we should make these the keyframes linear to make it more explosive. How about that? It's getting there. Now the next problem that we've got is that we want the pieces of our Voronoi Fracture to become dynamic, react to each other. They want to fall to the floor. They want to be affected by wind. Maybe, you know, they want to interact with particles and such. So they do need a dynamics tag. But then look what happens when we try to apply dynamics tags to this. So let's put a rigid body on. Let's say it's on. And okay, and that's simply because it's triggered immediately. So how do we make this follow the effector? Well, in our forces, we do follow position perhaps. Let's see what happens when we do follow position 100. And then, yeah, okay. So you can see that they are dynamic, but they're being held in place. So let's animate that off then. Let's get follow position to trail off near the end. So let's take this keyframe, put it at the start of the composition, and then frame 20, let's say, we're going to get follow position to go down to 0. That should work, right? Not really the results that we were looking for, huh? So what we need to do is we need to find a way of triggering our dynamics using some kind of data from each of these particles. It's not as scary as it sounds. I mean, it's not scary at all. It's a computer program. But in any case, it really is like a 10-minute thing. So buckle up. So here I want to get my Voronoi Fracture object to explode using a push apart effector, and then I want it to transition into dynamics. So I've got to turn on the dynamics for each one of these pieces dynamically. Well, how am I going to do that? Obviously I'm going to use Xpresso. So let's just go into our Voronoi object, right click, put our Xpresso tag in. What I want to do is I want to measure how far each one of these chunks is away from the center. So let's get Voronoi Fracture in. I'm going to change that onto use start position so I can copy this Xpresso tag to another object. Then I guess what I want to do is let's get a data node. Let's do that. Ooh, there we go. Right. Motion graphics data. So there's my object. Okay. So I've got my Voronoi Fracture object in there. Now I need the count. I need that count to be -1. So I'm just going to add -1. Let's do that. And the reason why I need it to be -1 is because the index goes from 0 to the number of objects that you have. So you need to take off from the number of objects, you need to take off the top number to get the proper count. I don't know, to get the index, sorry, from the count. So there we go. So -1, there we go. And then we get an iteration node. So it's going to go through all of the clones, and if we're giving it this index, then it's going to, oh, sorry, in the end, that's it. So that's iteration end. It ends at the last clone, right? This way. Then we're going to get another data node. Just copy this one across. And now the iteration, because we're going through the count, the iteration is giving it a different index number for each of the clones, right? So this little group here is what you call a solver. So anyway, so now the data needs the fracture object in there. There we go. And now we're able to get all of these little data types out for all of our nodes. So what I want is position. What I'll take is, I'll take the position of that object, and I'll take the position of the Voronoi Fracture itself, the parent object. So why not just take the global position there? So I'm going to take that position and I'm going to compare it to the chunks that spit away from it and see how far each one is. So what I want to do is measure that. So I need a distance node. So let's measure the distance between the chunk and the Voronoi Fracture objects. I realise it might be a bit too small for you guys to see this, so let's just make some room. So there we go. Our Voronoi Fracture object is here. I'm going to take its position into the distance node. There we go. Now let's try and see if we're getting any results. Just see if there is a result like that. Yep, we're getting a result. So now I think what I want to do is I want to compare these results to, let's say, a distance that I give it. So if I get, let's make some more room. If I bring in a sphere object and that represents the sort of boundary point where I want, let's just put it under there, and then bring it up. It's making it angry. There we go. So I want this sphere to be the threshold point. Once they come outside of this sphere, I want their dynamics to turn on, right? So what I'm going to say is I'm going to grab this sphere and I'm going to call it threshold. I'm going to bring that in and I'm going to grab its radius in there, right? And I want to compare that distance to that threshold. So I'm going to get in my compare node. So it's in logic compare. There we go. And I want this to be true. I want it to be on if the chunk is further away than the radius of our threshold sphere, right? So, boom, boom. Now let's get another result node, put it in here. And this one needs to be on bool because I want it to say true or false. So at the moment it's false. But anyway, this gives us the ability to trigger each of these chunks individually. Now let's just put this threshold on a different mode. I want it to be like that. Yeah, okay. And also I'm just going to make it like a stupid color so that you don't confuse it for geometry. Right, there we go. Boom. So now we're telling it outside of this red sphere, you're going to fall to the floor, but you're going to have the velocity that the effector, the push-apart effector, has given you. Right. So how do we do this then? Let's go into our Xpresso setup. And what we need is a bit of organization, obviously. Let's just throw these up there. And then just say, these guys are friends too. So like, let's put these in a little group here. Okay. And you go there. Now, this output, this true or false one here, this needs to go into another kind of node too. So it's going to be called a, what is it? Dynamics body state. That's the one. Right. Now, it's funny, it's got this object input. You actually, because the dynamics tag is a tag, it needs to know which object the tag's on. So we just get our Voronoi object output and put that into the object here. There we go. Now, you see all of these cool things, point of application, local point of application, add torque. There's loads of cool options in here. The one we're looking for is trigger. And now this trigger thing on this specific node, if you've ever wondered how you get xPresso to work, it's this node and this trigger thing. Not that they tell you. Okay, so xPresso is on in our tag, and the trigger is obviously going to be comparing our sphere, let's make some more space, our sphere to our chunks. However, we haven't told it how to compare it yet. I want it to say, if you're above the radius of the sphere, then you're a dynamic object, okay? So, let's see if I've been bullshitting you or not. Now you see, I forgot that I'd done that little failed experiment to demonstrate why I'm doing all of this stuff. I'm just going to take off the follow position and try that again. Okay, so while I was right and I did actually make them trigger at the right point, you need a bit of overlap between the effect of the effector and the dynamics coming on. So if I go to my radius keyframe here, and then after I go continue after, and then maybe I want to make this less extreme. Maybe I want to bring that down so it's a bit more shallow. If we go in our F curve, you can see the effect that it's having. So by 50 frames, we're going to be at like 100. Yeah, that's not too bad. So let's rewind and play. It's very subtle now. Where's that keyframe? Let's get that keyframe. Let's put that up a bit. Let's make it a bit more explosive. A bit more. That's it. And now if we really zoom out, you can see these are going mental. And they are interacting with the environment. They are bouncing on the floor. And that's the basis of how you get your explosions to work in Xpresso and Mograph. Now there's one final step that we need to make in order to make this actually properly work. If we just play the explosion as is and we zoom out, we can see it is yes, going a bit crazy. But I can't be sure that these are all being triggered at the exact right moment. And it took me looking at my Gumroad scene file, which thankfully was correct, to work out why the tutorial wasn't quite working correctly. Dynamics body state can evaluate each of these clones, these instances individually. But to do that, we just need to add an object index so it knows which object to look at, and then take our index number from the iteration node and plug it into there. And that means on every single frame, every single object in the cloner will go get evaluated and send its status to the dynamics tag. So now let's have a look at this explosion again. And you might not be able to immediately appreciate why that's different. However, if I take our thresholds down to, say, 80 and play again, you'll see that the ones at the bottom sort of fall to the floor in a bit more of a natural way. Now let's unplug the object index, play that again. And you'll see that they all go blast into space. So clearly, these few at the bottom were not being turned on soon enough in order for the dynamics to come to be turned on. So let's just do that one more time, just to prove that I'm not crazy and I'm worthy of teaching this subject. Play again. And there we go. Now this red threshold sphere is actually doing something. So let's make it bigger and let's wait for those dynamics to turn on. And you see, no matter how close it gets, I could put this, let's say I could get this radius right up to the very edge, and provided that in our dynamic settings for the scene, provided that we've got enough steps per frame, and I've just got this on 30, which should be enough, we should be able to, even though it's right next to the floor object here, this gap is tiny outside the red sphere, we should be able to see that even then the chunks bounce off the floor. There we go. So that's a really important final step, and we'll do exactly the same thing in our xParticles setup. Art directing the explosion. So obviously the pieces are going buck wild at the moment. We need a bit more control over how they move. Now if we come in here and we make our radius smaller, they'll fall to the floor. And that's nice and slow. We can see kind of what we're doing at this point. Also, I'm going to go into my dynamics and I'm going to go into timescale, and I'm just going to make that maybe 20%. I think maybe we should put a ramp on it as well. So let's say when we first explode, we come over here. Let's just say it explodes like that, and timescale is 100. Put a keyframe in, and then let's ramp it down to like, I don't know, 10% at that point. See how that looks? I mean, once you've cached the objects, it'll be way less jerky. You'll get this really nice transition down. But also, you want to make sure that this isn't on nice eased keyframes. You want that linear. That's better. Right, now you'll notice that these chunks aren't spinning at all. And if you put a random effector on these chunks from the start, then your objects, your nice round lovely sphere at this point isn't going to be nice and round, because all of these chunks will be rotated. So let's just try that. So let's put a random effector on, and obviously you see the effect of the random effector at the very start. It's horrible. So what we need to do is find a way of transitioning how crazy the random effector is. So we want these chunks to spin in all directions, and we want that to sort of evolve over time. I can't think of a better way than to do it in Xpresso, I'm afraid. So let's go back in here, and I'm going to get my random effector, and I'm going to get a time node. So let's come in here, time, let's get a time node like that. And yeah, like probably a range mapper would help at this point. So let's put one in. So I want frames, I want time, frame, random. And I think if I go in the effector, yeah, what is it? Parameter, transform, rotation. You know, it's much easier to just get your stuff up in the attribute manager, get the one you want, and just drag it in. Let's just get that in. So rotation on. Maybe actually rotation, no. I think we need to get all three of these actually. So can we drag the, let's see. Yeah, cool. So I'll get rid of those. Okay, so let's see what happens now. So anyway, this range mapper is literal, so let's make it a bit more crazy. 3, maybe make it a bit less crazy, 0.5. See, we're getting a bit more natural spin on the particles there. And that's simply because even though Mograph is a particle system, it doesn't have like a built-in spin system. And the other particle forces don't have a spin option either. I mean, there is TP spin, but you don't want to get into that here. So let's just make sure that at the start of this, our random effector is off. Okay, so let's animate something. Let's animate the strength of this effector. So 0 here, and I want it to come to about 100 there. Let's do that. Not bad. So let's get rid of the cursor. Let's get rid of the tracer. I think let's put our time up. 5 seconds. Might need more. Let's do 10 seconds. Okay. Pretty good explosion, no? The project files for this tutorial are going to be available on my Gumroad. Here is the free version. Here's the Xpresso setup that I just showed you how to make. It explodes like this. It's okay, but the fragments don't spin. If you want them to spin, you've got to pay me money, and you get this lovely thing with the detailed explanation. It's very nice. It's a very big Xpresso setup, which is really cool. And this one explodes like this on a frame that you can set. And look at that, beautiful, lovely stuff. And then there is the xParticles version of this tutorial scene file. And the xParticles one is pretty cool because basically you can come in here, let's turn that off. The xParticles one works so much better. It's a little more involved. But the results are way more realistic. The spin on these particles is real. They all spin at slightly different rates. Yeah, it's lovely, and it's probably worth the money. Let me just move that up. There is a bit more setup involved in this one. It's a little trickier because you have this object list here that you need to make. But I've already explained how to do that in the tutorial. So if you go onto my Gumroad, it'll be listed in the description below. And yeah, please give me money so I can do more of these. Thanks very much. Let's get a sphere. We will then do a Voronoi Fracture on it. And then if you've got Cineversity plugins, you can even paint your own fractures on it like that. Pretty cool, huh? We've got our Voronoi Fracture object. We make it editable by going current state to object. And then what we're left with there, if I turn this off, is a perfect copy, which is just the mesh objects. So let's solo that. And you can see nothing much has changed. Now I just want to store these positions in space, but I can't use nulls. So because the particle xParticles doesn't recognize the position of nulls. So I need to clone from these positions. So what I want to do is just get in a default little polygon here. I'm just going to make it -z. I'm going to make it 1 centimeter. There it is, tiny little thing. I'm going to hit C, make it editable. And then what I want to do is replace all of these sphere fracture parts. Going to get all of those, and I'm going to replace them with polygons. The way I'm going to do that is I'm going to come over to character, commands, and replace with. I'm just going to double click my polygon, and there you go. You can see you've got all of these polygon objects. Now that's just storing the position of all of those things. Don't need to see it, don't need to think about it even. But what I'm going to do is I'm going to get all of these Voronoi Fracture points. Now that let's turn that on so we've got something on the viewport. I'm going to get all of those Voronoi Fracture points and I'm going to put them into an xParticles fragmenter. And the reason for that is because I want this fragmenter to tell us, you know, where everything's going. So I can't do that until I've got an emitter. Let's just put in an XP system. Get an emitter. I'm really running out of space here. Let's undock that. I'm going to get this emitter. I'm going to go to here, object, defined emission, and that's going to be fragmenter list, like that. Same thing on the fragmenter, just get the XP emitter. Now these two things know each other. Going to get objects, twirl that down, lock it off, and I'm going to get here, I'm just going to select children, deselect the top one, there we go, drag them in, and now that XP fragmenter has all of these vector coordinates for each of these fragments. This is great, doing well. So now we want this emitter to be obvious. Let's turn off our Voronoi Fracture and see what happens if we hit play on the emission. And see they're just coming out from those faces. It's really hard to see here. Let me just edit our XP emitter display. Let's put that on lines so we can see. And also, I don't know why I would ever want that xParticles icon in the viewport. I'm going to put the speed of these particles down to 0 because I want the modifiers to do the work. So let's put speed 0. There we go. Hanging in space they are. Very hard to see as well. I want to then explode these away from the source. Yeah. The other thing that you need to do for this technique to work is turn on thinking particles, come up to simulate, go to thinking particles settings, and because we're not doing anything particularly fancy, just drag the all group into add to TP group. There we go. Beautiful. Lovely. It does that automatically. I just prefer to have something in that box. And I'm going to ensure matching coordinates because, yeah, why not? Okay, so then what I want to do is make these particles explode away from the center. And let's say we put in a Mograph cloner with like a, I don't know, like a little ball in it. Let's do that. So let's just put in a little ball under there, this Mograph cloner, and we're going to put that on object mode, and we're going to put the TP group here, all, drag it in there. Right, so now we can see what we're doing with our particles. Very good. So what I want to do is I want to put in a modifier, motion modifier, explode. Boom, brilliant, lovely. Not that it matters because dynamics objects have gravity by default, but I might as well just put in a, you know, whatever. Just put in a gravity just for the hell of it. Don't do that. Do this gravity. Yeah, why not? And then just maybe vary it a bit, which makes some of them denser and some of them not. I don't know. That looks good. Let's maybe like, yeah, that's a nice explosion. Now, how do we apply this to our Voronoi object? Well, if you remember, a Voronoi fracture is a Mograph particle object just like a cloner is. So what we can do is we can come into our effectors and then get an inheritance effector. So we're going to inherit the cloner's movement. So position, scale, rotation, all this shit. Let's do that. So this inheritance, let's go in here and set it up. The objects that we're trying to inherit from is the cloner, and this is direct, and morph motion object just means that it copies the animation of the clones across. So this Voronoi fracture now has this inheritance in. And if we turn the cloner off, but not disabled, just invisible, right? If we turn the Voronoi Fracture on, visible, then we get our chunks moving out. And that's the basic way that you get X particles to control explosion. Now, if you notice, we've got the same problem with these chunks in that they are not spinning, which is really annoying. We want them to spin like it's exploding properly. So in xpEmitter, we go to extended data, we use rotation. If you ignore rotation, that rotates the emitter itself pretty much. If you do simple spin and then just go buck wild on these, like boom, 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 that should put some spin on the particles. But if you see, it's not really doing all that much. So yeah, so these particles aren't spinning very nicely. If you see what happens, they're just coming straight out. And now actually, I'm going to turn that detailing off because it's making it slow. There we go. So it's just coming out and each one's just coming out linearly. It's quite boring, right? What we need to do in this case, we need to get the spin that is being generated by X particles, and we need to get that into thinking particles. And here's a setup I made earlier, but we're going to recreate this, right? It's quite simple. Because X particles has nodes for Xpresso, we can literally just, grab the data we need, copy it over, Bob's your uncle. So let's go Xpresso tag, and we need to get our xpEmitter and we need to get the data. So get data, get particle data from our, let's just go and select our emitter. What data do we need? Well, this is interesting. If we go to spin, then we get p spin. That's not that useful. We need spin convert. And then we need to set the data on our thinking particles, and we're going to get the spin in, right? So spin convert. And the reason we need to convert it is because if you look here, our X particle spin is in a vector and our thinking particle spin is a proprietary format that we can't read. So we need to use this node. Let's get the speed and the axis from X particles. So let's go speed. That's great. Goes straight in. And we get axis. So in order to do axis, we need to go rotation. And we need to convert this from a vector to a normal. So to do that, we're going to get our universal adapter. I'm going to just plug that in, turn it into a normal, and plug that in there. And see what happens when we press play on this. Oh yeah, set data will actually need us to put in our all particles. So let's just go in here and pass. We will pass our all group over to the set data. So set data is going to be in the all, right? Makes sense-ish. You see they're spinning really fast. Now, because we had to convert our spin from X particles, there is definitely a discrepancy in the data here. These things are spinning so fast, you can tell that something's wrong. So the first thing that we want to try doing is try to decimate the numbers coming out of X particles and see if thinking particles chills the fuck out. So let's get our speed, and our speed, let's put that into a range mapper. So we go to Xpresso, calculate range mapper, and we're going to go speed in, and we're going to go speed out. Now in our range mapper, let's say the speed going in is 1 meter per second, and we want to decimate it, so we want it to go 10 centimeters per second. You could go 0.011, yeah, and see what happens. You just get a 0 here. Instead of doing that, what you're going to do is you're going to put in the zeros behind the input upper instead. You can put in as many zeros as you want in input upper. 1. Oh yeah, we need... it would have been good, by the way, if I'd put that back to where it was. Okay, let's try that again. So, 1,000. 100. That's getting there, isn't it? Maybe even a bit too fast. I'll show you 10. 10's crazy. So let's do 200. That, my friends, is pretty much exactly where we want it to go. And now we have the same issue. Now we've butted up, and that's going to be the next section, but now we've butted up the issue of how do we get this Voronoi fracture, these objects, to interact with their environment and each other. And that's going to be the next section. In order to trigger our dynamics tag individually for our chunks using xparticles, I've come up with an XP question that seems to work almost every time. Now, if you look when I play back, we still get that second frame jitter, and that's because the emitter object itself, if you look down in, where is it? On frame here, that's set to 1. Unfortunately, using the fragmentalist, there doesn't seem to be any way to get around having that on 1. So I think you're always going to have that jitter, but it's really easy to use the traffic lights to swap out objects, like, you know, the non-dynamic object for a dynamic one. But anyway, I'll show you how to build this setup, because using a fall-off, it seems to be the best kind of way, and it's also a very visual way of getting these things out. So if I play this now... yeah, do something. Alright, there we go. You see that they have very natural arcs on them. Let me just pause and show you. They have very natural arcs on them. They're not kind of suddenly remembering that they're dynamic and then just heading for the floor. They're actually sort of, you know, quite well arc directed. And the spin on them is really nice with xparticles. So, I guess I should probably try and build this setup from memory. Let's then just disable this Xpresso tag and try and do this again for your benefit. Okay, so let's add an Xpresso tag to a Voronoi Fracture. And in here, I want to get, let's say I want to bring in our fragments emitter here, and I want to just feed that object out. Then I want an iterator, and this is the xparticles iterator, which it works exactly the same as iterator, except it's so much easier to set up than the Xpresso one. So fragments goes into there, and then I want my question node, which is another really good thing from xparticles. So all of these question objects that you get in xparticles, well, up here somewhere. All of those questions, you can do it all through this node, which is really good because you can hook up stuff from xparticles to stuff from thinking particles and Xpresso. So let's get that emitter in here. And then our index is going to be the iterated index. And then the question I want to ask is it outside of a fall-off? So if I could say, where is it? It's called outside fall-off, isn't it? Or something like that. Modifier fall-off, and then particle outside fall-off. That's the one. Okay, so in this case, what I had is I had just a gravity effect, a gravity modifier. And all I did is I just came into the emitter and then where was it? It was like modifiers. I put it in the exclude group. So it's not actually doing anything at all. It's not applying gravity to anything. But what it does have is it's got this lovely fall off here. And then I just used my threshold sphere here. And if we look, I'll just bring that in, that threshold, and I'll bring in its radius like that. And then I'll take that trigger fall off, and I'll bring the size in there, And then all I did was convert that, was it reals to vector, like this. So now the radius of that threshold is setting the radius of our fall off. Perfect. Okay, now if I set this threshold bigger, there we go, you can see the fall off is going with it. And that's quite useful because now this question will return true if these particles are outside the fall off. That's very good. So what we need to feed that into is the dynamics body state tag. And we're going to need our Voronoi Fracture in there to tell it which dynamics tag to look at. So go in there. Then we need our object index, and you can use the object index that comes out of this XP iterator here. So that's quite useful. So let's get our object index and take it from the XP iterator. And then we just need our trigger, and trigger goes there, and that's obviously coming from the question. And then the next thing we need to do is that the XP question doesn't actually know where our fall off is or what our fall off is. So let's bring in our gravity object, the gravity modifier that I've just renamed dynamics trigger fall off, and go in here and test object. So it's going to test our dynamics fall off like this. So let's come in here, go objects. And if you see, that's exactly the same node. I could have just hooked that into there, but I didn't. Anyway, so let's see what happens now. There we go. You can see that at a certain point, they're all being turned on individually. And because there's a variation in the xpExplode speed, you see I've got a variation of 250. Using a distance traveled or using a fall off or using anything that's sort of from the center of the object is quite useful because they're all going to reach that point at different times anyway. So you will get a variation in when their dynamics tag is turned on individually. You're not just going to have them all suddenly just fall to the ground at the same rate. So project files are going up. Like anyone that actually gives me money will get like proper project files with everything in it, with proper sliders and like help files and shit. If you don't give me any money, you can just have it and rip me off and probably make your own tutorial about it. But anyway, yeah, thanks for listening. Cheers. Bye-bye.